For the introductions, the samples obtained from boreholes and excavations are used to make rock descriptions, which plays an important role to the determinations of its engineering properties. This discontinuities is the most crucial part when describing a rock, and although the name of a particular rock can often determine the range of typical engineering characteristics. The properties of rock cannot be concluded simply from this type of geological classifications. This knowledge is also very important for the construction purpose, where the rock materials are needed to initiate geological correlations between borehole as well as to distinguish boulders from bedrock. The classification of rock materials is very essential to appreciate the geological origin and area structure.
So the objective of the experiment 1 is to obtain physical description and RQD of rock cores recovered from borehole drilling. Next, for the theory of the experiment, rocks in the form of natural outcrops, cores, and excavated surface should normally be described in the following manner. First, material characteristics such as strength, structure, color, texture, grain size, and rock name. Second, general information, additional information and minor constituents, geological and information. And the last, mass characteristics such as state of weathering, discontinuities, and fracture state.
Next, the calculation for core logging task. Based on the data given, there are two core, which are core A and core B. Length of the both core are 1500 mm. These are the formula that will be used. Core recovery equal to length of recovered sample divided by the length of core barrel times 100%. While for rock quality designation, or we call it as RQD, the formula is equal to summation of all core pieces larger or equal than 100 mm divided by the total length of recovered times 100%. Next, based on the data given, we can get core recovery and also rock quality designation for both core A and also core B. This is the steps. And finally, we will get the answer. As for core A, CR equal to 100% and RQD equal to 61.33%. For core B, CR equal to 100% and RQD equal to 79.33%.
Okay. Next, we will move on to the discussion part for G4 experiment 1. So, based on the experiment, the values of RQD for each core are as below. So core A is 61.33% and core B is 79.33%. So by using their UCS value, we can determine their rock quality based on the rock quality designation table on the right side. So we can conclude that core A has fair rock mass quality since the RQD value of core A is in the range of 50 to 75%, and core B it has a good rock mass quality because the range was in between 75 to 90%. Okay, after that we can also determine their core characteristic for two core sample. So as a result, we can find that core A is moderately weathered rock and many part of it has broken into small pieces, and for core B it is slightly weathered rock and a few part has broke into small pieces. Okay, so that's our discussion. Thank you.
Based on the experiment, we have provided an accurate record of the core samples using core logging method. We have determined the RQD values using formula and data given. Based on the calculation, we have also determined the physical description of rock core. Hence, we can conclude that our objective has been achieved. We found that core A is classified as fair and moderately weathered rock and core B is good and slightly weathered rock. Lastly, we can conclude that core A is suitable to use in construction due to its sustainability.